probably one of the most difficult things to do with a plasma cutter is to cut accurate holes. Now, the trailing arc effect that we just discussed has quite a bearing on this problem. Now, the reason is because when you're cutting a circle, the machine's continually changing direction. It's almost like you're cornering continuously. Remember the corner we drew earlier, how it had that cut underneath? Well, imagine if you're going around in a circle and that trailing arc is always trailing behind in the previous direction. You're actually ending up with the effect similar to a caster wheel on a chair. If you were to move it around in a circle, that wheel isn't pointing directly behind, it's pointing partially towards the previous direction. In fact, it's leaning towards the middle of your circle. And the arc does the same thing. You're going to end up with a hole quite often that tapers in. It's smaller on the bottom of the plate than it is at the surface. And that's simply an effect of that trailing arc. So how can we overcome the trailing arc effect on holes? How can we get good quality holes? Well, the first thing is probably your expectations. Now, generally the thickness of the plate is a guide as to the minimum diameter of circle that you can effectively cut. For instance, if you're cutting 10mm thick plate, try not to expect the machine to be able to cut a circle smaller than 10mm. It's just simply a difficult thing for the machine to do, and quite often you're going to be disappointed. Now, there is ways to minimise the effect. First of all, remember I talked about if you spend too long on the corner of your piece, it will melt the bottom of your corner. We can actually use this to help us. If we slow the feed rate down as we're travelling around the circle, it allows the arc to burn away more of the material below and will tend to counteract this leaning effect of the arc as it trails. So one thing is slower. Now, going slower will generally give you a little bit of dross, but if the result is a better hole, then it's probably well worth it. The other thing that you can do to overcome this tendency for the holes to lean in like a funnel is to go lower. So slower and lower. The reason is, remember we talked about the arc having that flames sort of shape. That means that if we get the torch lower, closer to the material, it's going to tend to also want to do an undercut. And this can counteract the effect of the plasma wanting to leave that taper. So lower will also give you an improved hole. There's another factor on holes that causes problems with quality. It's not to do with the trailing arc, it's to do with your height settings. There's two settings that are very critical to getting a good quality hole, and that's the cut height setting and also your ABC setting. Because you're piercing in the middle of the hole, the pierce isn't going to affect the quality of your circle. The machine then drops to the cut height setting. It's this cut height setting that the torch is travelling at during the first stages of your circle. The machine will travel through the lead-in at the cut height, it will slow down and change direction, and all of this is happening at the cut height. As the machine travels around the circle, if the circle's big enough, the AVC setting will kick in. Now the AVC voltage has to match the cut height, and you'll do that through experience. You'll automatically know how you need to compensate the AVC to achieve the best height. But let's say you had the AVC setting set too low. When the machine gets up to speed, the AVC is going to tend to want to lower the torch. So after this point, the torch is going to start dropping to a new height, which is going to match the AVC voltage. If you're travelling higher, remember you're getting a wider cut, less distinct and wider. That means that the start of the cut will probably tend to go outside of your desired line. So you're going to get a wider cut initially as you're starting to travel. Once the machine starts to override the cut height setting with the AVC, it's going to drop to the correct height. Now, what that means is your cut is actually going to be narrower at the end of the circle than it was at the start. And you're going to get this step where the lead-in finishes. So how can you improve that effect? Well, if you were in fact getting a wider cut to start with and then it was getting narrower, you would lower the cut height setting. Or alternatively, you could raise the AVC setting so that the cut height is maintained constantly during the circle. Of course, if the cut was narrower at the start and then got wider, it would mean that the torch was climbing up during the circle. And that means you probably need to lower your ABC voltage so that it doesn't increase after it leaves the cut height setting. There is one last setting, which is to do with the AVC, and you'll find it on your ART machine, and it's called the AVC off percentage. Now, this is a setting that's different for every torch, for every consumable group. What it means is the machine will stop trying to track the material until it's above this percentage setting. Now, most of the time we have the percentage set around about 30 to 50%, sometimes 60%. So as we stated earlier, when the machine's going slow, whether it's cornering or travelling around a small circle, the machine won't allow the torch to track up and down. It'll hold it fixed firmly. So by increasing the AVC off percentage in the machine settings for that particular torch, you can increase that up to say 70 or 80%. Because the machine is travelling around a circle, it's not going to achieve the full cut feed rate. So that means for most cases the AVC isn't going to be functional during the whole circle. And that means it's going to continue cutting at a constant height, and that will give you the best results when you're cutting your holes.